should just review it before I hand it in.
Yeah.
Thank you.
There you go. We're going to vote. We're either going to do P for pure substance or M for mixture. And we're looking at this right here. Okay? And the way you do the letter P, this one's actually a little tricky. You got to put your pointer finger straight up. You got to put your middle finger sort of on an angle. And then you put your thumb in between. And then you turn it down like that. That's a P. Okay? All right, so fingers like that, thumb in the middle, P. And in order to remember that, yes, it is representing what you might think it is representing. P. Yeah. Okay, anyway. And if you didn't get that, God bless you. Okay, so that's a P. And then a mixture, because back in the day, we used to do cursive writing, and an M was like this. That was an M, and this was an N. Okay, so an M, we take 3 fingers and we curl them over our thumb. 3 fingers over our thumb, and that's an M. Okay? So you either have a mixture or a pure substance. A mixture or a pure substance. And if you're like, I cannot do that, Ms. Spence, this is just too complicated for my poor little hand to deal with, you can go mixture, pure substance. Okay? I'm okay with that too. Or it's also okay at this point to be like, I don't know yet. Okay, that is also, I don't know yet. That's a perfectly good vote. Are we ready to vote? Okay, let's do it. 5, 4, 3, 2, vote. I got pure substances, I got mixtures, I got all kinds of things. Okay, so what we've got here is we have, say for example, this might be Na plus, and this could be Cl minus, and those two things are together. So you have Na plus Cl minus. There's an Na plus Cl minus particle. What do we have here? Na plus, Cl minus. What do we have here? I mean, it's reversed, but it's the same thing, yeah? If we flip the cube over, it would be the other way, yeah? So it's Na plus Cl minus. So are all the particles the same? Are they all NaCl? Yes, they're all NaCl. And if they're all the same particles, then is it pure or a mixture? Pure. And I know it's a little confusing. It kind of looks like a mixture because it goes positive, negative, positive, negative. But if you look in them in little groups, it's like positive, negative. That's one particle. Positive, negative. That's another particle. And they're all the same as the ones next door to them. Okay? Also, take a look at this. What did it say at the top? They're pure. What's pure? Compounds are pure. Are ionic compounds compounds? Is that an ionic compound? Yes. And if it's an ionic compound, then it's a compound. And if it's a compound, it is pure. Okay? What do we know about elements? How would you recognize an element? Just one type of atom. So we have maybe is that an element? Okay, I've drawn that one a little bit big. Sorry. Let's get rid of that one. Make it.
Oh, it is.
Yeah. If I don't have that one. Yeah. This is a diatomic element. Okay. So those are your pure substances. What do covalent compounds look like? They aren't crystal lattices. Covalent compounds, what do they look like? Yes. Molecules. They share their electrons. So you might have something like this. Is that a pure substance or a mixture? Pure, because all the particles are the same. If it's a pure substance, what are the two possibilities? It either has to be a compound or an element. Is that a compound or an element? That is a compound, so that is a pure compound. This one up here, that's a pure element. This one up here, this is a pure compound. Okay? So if something is pure, it's either a compound or an element. If something is a mixture, what are the two different types of mixtures? Chat with your partner about that. What are the names of the two different types of mixtures? They both start with H. Heterogeneous. And the other one is homogeneous. What is the other name for a heterogeneous mixture? Yes, it's a mechanical mixture. What is another name for a homogeneous mixture? Yes, a solution. Okay. Which one do we have here? This one up here. What is this? Homogeneous or heterogeneous? That is heterogeneous because it has clumps, groups. Okay? So heterogeneous has clumps, groups. Homogeneous has no clumps, no groups. Okie dokie. Okay. What if I did like this? Thank you. Homogeneous or heterogeneous? Do your best. Does 2 represent a clump? No, 2 is not a clump. Okay? That is a homogeneous mixture. That is a solution. Okay? Are we feeling better about this than we did, say, 15 minutes ago? Yeah. Okay, do we feel like we could do a quiz on it tomorrow? Yeah. I got people grinning at me like this. In order to practice for it, you could have you done page 13? Have you done page 13? No. Why don't you guys do page 13, and while you're doing page 13, I'm going to reprint pages 19 and 20 for you, because then you can do them again. Okay? So everyone, you're working on page 13.
I like the whole head. That is your And the hair is not the pose is really dumb. The poses of this drawing, but I like the pose. It's very, and I'm very lazy. It's so true. I remember how to draw one. He's like the greatest, one of the best.
One, two, three, four. Okay.
Buddy's had tough life. You know who also got hurt? You know who also got hurt?
Okay, you have the next 10 minutes to either work on this, which is just pages 17 through 20 in your book, but I've printed it again so you can do it again. Or if you would rather do some review that's in the book, but you won't have it then for the test review, because this is test review, you could do pages 75 through 80. Okay? I would advise doing this one because it's directly related to what your quiz is on tomorrow. Okay?
Okay, I just actually know how to spell homogeneous. Can't be that hard. Homogeneous. So I'm gonna not. No wait. Wait. Oh my god, that's so stupid. Heterogeneous.
Look, my head is covered.
Oh, this isn't a mixture at all. You have your laptop. Locked in. So long.
How do I elaborate on that more? That's actually so good. Like that. Which is a mixture. Like elements are mixed up.
It's not elements, it's compounds or elements. Any parts of the I'll just sew it myself. Yeah, we have one person who makes that. And this is the fire, like, I think we have like 20 kids do it. We have a lot of people. It's like in the streets, and one person is that's a lot. How many cheers? Most of it's a hard.
But like it's just dead.
Exactly. And then just like a little.
Yeah.
That's a pure substance. It's fine. It's fine.
I know it's
It's and solid gas. Sorry, liquid and gas. It's different elements. It's fine. It's fine. It's fine. Why is this really pure?
Did someone take notes on floor models? We have also the picture of a Viking helmet and a robot. Anyone recognize the Viking helmet and the robot? Would you like your notes back? No one? No one's claiming it? Okay. It's going in recycling. Going once, going twice, going
letting people that don't like anime enjoy.
Exactly. Is it still pure if it's natural elements?
Are the elements? Yeah, no.
I mean, it's hard to. I don't like
No. Best part about drawing in, you don't have to render because you're unless you draw. It's not red enough. I don't think I own any Oh, that's so true. No. You're drawing an expression, you're like the expression. of
Okay,
your-
friends, 2 minutes, then we're doing something new. Okay, 2 minutes.
down.
You know what hurt? When he punched me in the arm, that hurt so bad.
Question from the English section.
Yes. Yeah. Yeah.
Like, it's not in my schedule.
Buddy, the stuff in my sketchbook is absolutely garbage.
It looks so messed up, but I don't really care.
Okay, now I need to make the arrow look cool.
Okay, friends, we're going to be on page 41. 41. Okay. Phew. Okay. All right. Page 41, or actually, no, we're on page 42. Page 42. All right. Okay. Sound needs to be on. And we're going to make this bigger. This is a bit of a weird little video, but we're going to watch it
Oh, wait, I know.
because it is the best representation of covalent bonding possible. But it is a weird little video. It's like you've walked into some really strange realm. But here we go.
Huh? Huh? Oh.
Okay, so you guys are going to fill in the blanks. Noble gases have what kind of electron shells? Complete outer electron shells. Which makes them, can you guess what the word is? Stable. Stubble.
Oh.
Now, do you remember on your test there was a question where we asked about the reactivity of noble gases? Does this noble gas want to react? No, why? Because it's already stable. What kind of bond was that? That's a covalent bond. Okay, so in order to get this kind of stability, we're still filling in the blanks. Other non-metal atoms come together to achieve this noble gas configuration. So you're filling in the blanks. Noble gas configuration. If you don't like the word configuration, you can just write arrangement. Okay, that's the other way of saying it. This coming together and sharing of electrons, so this coming together and sharing of electron pairs leads to the formation of a chemical bond known as a covalent bond. Because they're unstable. They do not have a full valence shell. What? Oh, they're all spread out rather than paired up. Because many people do their Bohr models like that. It's just less useful when it comes to showing where atoms actually end up in relation to one another. Okay? Having them paired up is a better bridge to stuff you'll learn in grade 10. Okay? Because in grade 10 you'll learn a shortcut called a Lewis structure, which is a shortcut for Bohr models, which means you don't have to draw all those circles anymore. And you just draw dots. Right?
Why can't we learn it now?
Well, if you're keen on learning Lewis structures, I can get you some resources, okay? Okay, so the chlorine atom, this is down at the bottom of the page on page 42. A chlorine atom has how many electrons? 7 electrons in its, what kind of shell? Valence shell. And it needs 1 more electron to attain stability, to complete its, oh, and this is a new word, octet. Why do you think we call it an octet? Because there's 8 electrons. Oh, sorry, I should not have gone ahead yet. Let's finish up. There we go. Make sure everyone gets to finish that. By the way, if you're working on the enriched stuff and you want to, you can just draw the outer shell and skip the inner shells. Okay, you can be like, this is way too many dots. Okay? Okay, are we good to move on now? Yep, okay. Okay, so filling in the blanks on page 43. 2 chlorine atoms come together and what do they do with their electrons? They share their electrons to form what? A molecule of chlorine. Oh, we'll fill those in a minute. They'll pop up. Okay? In this way, each atom will have 8 electrons in its what shell? Valence shell. Okay. So Ryan, you were asking what goes in the little boxes. We have a chlorine molecule. And here we have a single pair of electrons is being shared. 1 pair. And that is called a single covalent bond. Okay, and we also have right under where it says note, a full valence shell containing 8 electrons is called a complete octet. It says as a single pair of electrons is shared between them, the bond is known as a single covalent bond. And how do we represent that? We draw a Cl, and then we draw a line, and then we draw a second Cl. Okay? Okay, are we ready to move on to oxygen? Okay.
Yeah.
Oh.
I told you it was a weird little world we have entered. Okay, so this is oxygen. How many electrons does it have in its valence shell? It has 6 electrons in its valence shell. How many more does it need? It needs 2 more electrons to complete its, what's that word for the full 8? Octet. So to complete its octet. So oxygen will share 2 of its electrons with another oxygen atom. And once you finish page 43, we can flip to page 44. Okay, so here we have an oxygen molecule. So we're up at the top where it says oxygen blank, you can fill in molecule. And then that first dot, when 2 oxygen atoms come together, how many pairs of electrons are they sharing? 2 pairs, that's 4 electrons in total, 2 pairs. That's not a single covalent bond anymore. What do you think it is? It's a double covalent bond. Okay, so they each share 2 electrons, meaning 4 in total, to complete their octet. Since they share 2 pairs of electrons, there is a double bond between the oxygen atoms. And if a single bond is shown by 1 line, how are we going to show a double bond? 2 lines. Each line represents a pair of electrons. Oops, wrong button. Okay, so you can fill in, we have 2 pairs of electrons. And that is a double covalent bond. Okay. And then we've just got one little thing left. I have no idea what this boy and the soccer ball have to do with anything. How many electrons are in the middle here? 1, 2, 3, 4, 5, 6. How many pairs is that? 3 pairs. So this is not a single bond. It is not a double bond. It is a triple bond. How many lines do we use for that? We use 1, 2, 3 lines. That represents 3 pairs of electrons. 6 electrons in total. Oh, no lines and angles. No.
In this video, we're going to talk.
Although that's the organic chemistry tutor who is like an amazing. If you go into science or math, like in the senior levels, the organic chemistry tutor is someone you will want to familiarize yourself with. Let's just skip to the end there, except for not quite that far. Let's make that bigger. There we go. It makes no sense, and I don't know why Oxygen is singing about Christmas. But to be honest, this is the best animation that I have found of covalent bonding, which is really sad. So if any of you go on to do wonderful things with your lives, perhaps you could make a video about covalent bonding that is not so bizarre. On the other hand, it does provide some humorous relief. So that's not all bad. What is your homework? Study for your quiz. Study for your quiz.
Oh, that's literally like. Oh no.
I think I could wrong side.
Let me get you a better. It's the glowing.
Oh, are you leaving me? Okay, bye, Sue. Actually, my phone's in my pocket.
There you go, guys. Finished. Good.
My
I'm pretty sure it's longer like so go up. And then it just. I know. It's like so sweet. Whoa.
Hey, no, wrong character.
Yeah. It's just fine. It's like John Kerry's fun. But I struggled with super. Okay. It's really. Bye-bye.
Bye, Cacciatore. Have a good evening. Oh my God, no more music. Good Lord. It's the most weird little